So we're looking at the evolutions of the avionics data transfer systems, specifically Arinc 429 to 629 transition. Okay, this transition reflects how the aircraft avionics grew from relatively simple independent systems into highly integrated digital networks. And while Arinc 429 is still very common, Arinc 629 represents an important step towards modern network-based avionics architectures. Here you see a picture of a Concorde. This is the Concorde. In the background down there is the instrument panel with the two pilot seats, and then this is what they call the flight engineers panel. Okay, where the flight engineer sits. Here is a radio operator. Here, a flight engineer panel here, where you can see there's 4,500 little instruments, each with a power source, each with a signal source, each with an earth cable going to each indicator. No, so just let that go through your head. Each indicator has 3 cables: a power source, an earth, and maybe 1 or 2 or 3 or 4 for indication purposes, what that instrument does. Okay, so and the reason we put that up is just to highlight, just to fathom the amount of cables that would be behind this panel. Okay, so early aircraft avionics systems relied heavily on point-to-point wiring, as you can see, with individual signals running directly between the instruments and the sensors themselves. As more systems were added, navigation, flight control, auto-flight engine monitoring, the amount of wiring increased dramatically. This led to higher aircraft weight, more failure points, and greater maintenance complexity, creating a strong need for standardized digital data buses. Okay, so we've gone from this to this. Okay, so within 50 years now, this looks like, I know the way the angle it is and everything looks like pilots are now lying down, but they practically are lying down. It's a very easy job for them nowadays. This is the A350. And you can see it's just a load of screens, multifunction displays. In other words, it's a display that you can actually adjust to display. It has multiple functions. In other words, you can use it for maintenance, you can use it for navigation, you can use it for a prime of flight display, you can use it for any purpose you want. So because of the Arinc now and its systems, you can make all these displays display anything you like. Okay, and it's become a very easy job for the pilot. And I'm talking, the display system is just one example of what Arinc uses, and we'll see in a minute why. So I just want to highlight here that Arinc 629 was patented by Boeing. Okay, specifically for the 777. So they improved on Arinc 429, and although subsequent users, even Airbus now, use Arinc 629, every time Airbus use Arinc 629, they have to pay royalties to Boeing because Boeing have developed it and patented the 629 concept. So if you look at 429, this is just a typical schematic from the A320 training notes. So it was introduced in the 70s. The standardized digital communication between avionics systems. You can see here, if you look at the arrows are one direction only. That's why for Arinc 429, they call it unidirectional, because you got one signal going away from it and transmitting, and then another signal coming to it, the box, to be able to receive. It became the dominant data bus in commercial aviation and is still widely used today on the aircraft like the A320. Its key design philosophy was simplicity and reliability. One transmitter sending data to multiple receivers with very predictable behavior, and then the multiple receivers would send the information back to the source or the other computer. Okay, so typical layout. I'm sure you've all seen one of these before. So the advantages of Arinc 429, it would be a 32-bit word structure. It would be labeled system identifier, data parity, data lines, data rates, and all that. It was a relatively low speed, or it was between 12.5 kilobyte bits per second, uh, and high speed about 100 kilobits per second. That was the sort of operating range, and it uses a twisted pair wiring. Invariably, this is a screen cable, and you'll see it throughout the A320. It's that light blue twisted pair cable that you see all over the aircraft. Okay, the limitations of it, as we said, it's only got a unidirectional communication only. In other words, there's one set of wires for the transmission, and then another set of wiring, twisted cable for the receiving side of it. So it requires many dedicated wires as the systems increase the limited bandwidth. We'll talk about that in a minute. So it's poor scalability for advanced integrated avionics. And it increases, because of that, it increases the weight, and the operational has operational consequences on the aircraft, because we're trying to become efficient and save weight, and then we put in all these wires and we got weight. It's like Boeing when they made the 787. They decided to put this to make the whole fuselage carbon fiber to save weight. And then they saved so much weight that they had to actually cool the avionics with coolant. Yeah, and it was the lengths they went to cool the avionics and do all these systems added so much weight that it negated the weight they saved when they made the fuselage. Okay, same here. We tried to save weight by becoming efficient. But then the systems, as they become more complex, we add wiring and add wiring and add wiring. And in the end, there's no weight saving. And this is through evolution, because we're adding computers all the time. And adding computers means adding a lot of extra wiring. By the 1980s, aircraft avionics had evolved to include flight control computers as well, flight management systems, and advanced displays. Okay, we talked about the displays. We use it now for everything. Arinc 629 on the aircraft and 429. So manufacturers needed a bus that allowed multiple systems to talk to each other on a shared network. And this was the goals were reduced. The goals were reduced wiring, higher data rates, and better system integration. This was why Arinc 629 evolved. Okay, so this is a picture from the Boeing notes depicting the Arinc 629 and its capabilities. If you think about it like apps on a phone. Okay, so you got your phone, and all these squares are different apps. So this is the ACMS, Airplane Condition Monitoring System, is one app. The Flight Management Computing System is one app. The Thrust Management Computing System is another app. The FDR is another app. The Primary Display System is another app. Okay, the CMC. Okay, all of these are different apps, and the mobile phone itself is the one that combines all these apps, then distributes, takes the info, and sends out the info to the specific app that's required. And that's how they designed this. And if you look at a 777, this is another picture from the 777 training notes. Okay, and this is flight control app. All right, and it is nothing other, you can see 3 colors here. It is 3 data cables. That's it. 3 data cables. They run the length of the aircraft from the nose to the tail. A green one, a black one. They're not green, black, and red. They're depicted here in green, black, and red. But they are 3 twisted pair cables that run the length of the aircraft. They connect at the AIMS cabinet, 2 cabinets where all the the mobile phones are, the hosts, okay? And then any unit, you'll see in a minute, that wants to talk to these data cables is connected to this data bus. And that's it. Okay, so 3 cables that run the length of the aircraft for all the flight control computers, all of these. So you got ADIRUs. ADIRUs are air data inertial reference units, a secondary air data air reference unit, 6 ADMs, so 3 primary flight computers, 4 ACE computers, and whatever that is, I can't remember. But you can see, all right, for these flight control computers, it's 3 data buses. That's it, 3 cables. Similarly, for all the systems, for all the aircraft systems on the 777, we have 4 databases. Sorry, 4 twisted cables, data buses, yeah, that run the length of the aircraft. Okay, 2 down the center. They call them center 1 and center 2. 1 on the left-hand side that goes out to the wing as well, and 1 on the right-hand side that goes out to the wing as well. And that's it. 4 data buses. All right, that all these computers connect to. So if you want to compare it, here's a comparison table between Arinc 429 and Arinc 629. And I always bring in my examples, this example in my presentations, this example here, because it's the best way to understand it. What is a unidirectional data transfer and a two-way or bi-directional, or whatever they want to call it. Okay, so if you imagine an Arinc 429 is like a walkie-talkie. I am here with my walkie-talkie, and you are where you are now with the walkie-talkie. I press to talk, and I transmit, and I talk to you. That is data transfer. In that time frame, okay, the only thing you can do is listen. Okay, when I finish my transmission, I let go of the walkie-talkie, the PTT, which means the end of the data transfer is there. You will receive the transfer. You will receive the data, process it in your head, think of an answer, and then you will press your PTT and talk back. Okay, this is unidirectional. Arinc 629 is like a mobile phone. Not only a mobile phone, it's a conference call. All of us now, it's like a WhatsApp call. Yeah, all of us have got our phone, and we're all listening to each other, and we're all talking to each other at the same time. Whether we can hear and understand each other is irrelevant. What I'm saying is there is no press to talk. It's an open line. Yeah, and everybody talks to everybody. That's the easiest way to understand the difference between 429 and 629. To see it in pictures, again, another picture from Boeing training notes. So you'll see the Arinc 629 data bus. It's just one data bus, one line. Okay. And the units, the LRUs, connect to it on a bidirectional data line, transfer line, bus, whatever you want to call it, to the card within the aircraft. Okay, unlike the Arinc 429 data bus, okay, where you have all the systems here for the data bus, and you have then 2 cables. Yeah, one as it's unidirectional, a transmit and a receive. Okay, for each LRU. Okay, so look at this: 1 cable, multiple cables.